Okay, welcome back guys. Today's lesson we're going to do something called trigonometry identities. Now trig identities, I believe one of the hardest topic in trigonometry. It's just because there's so many different forms that you need to remember. Okay, so let's start with trig identity first. Now I remember when I was a student, the trig identity is the question I find is really hard to do. Just because you have to memorize so many formulas and also you need to know how to apply each of the formula to the actual question. All right, start with the first set. The first set of formula is called the three reciprocal identities. Now, three reciprocal identities is pretty easy to understand, and we have done this before. So it's like, the first one is cosec theta is equal to 1 over sine theta. We know that, right? I've already introduced to you guys the other trig ratios. Then the next one is sec theta is equal to 1 over cosine theta. And then the cotangent theta is equal to 1 over tangent theta. So this is pretty easy, right? They're pretty easy to do. It's three reciprocal identities. Alright, so you do need to know how to use them. You do need to know how to go from the left hand side to the right hand side and vice versa. So for example, I can write sine theta equals to 1 over cosec theta. And that's the same for the other two. Alright, you need to be able to do from the left to right and the right to left. Alright, so that's pretty easy. The next one is called the ratio, two ratios identity. Alright, so what are the two ratio identities? It's the tangent one, so that we know that tangent theta is equal to sine theta over cos theta. Alright? Now the reason for that is we can actually prove it using SOHCAHTOA. We do know that sine theta is equal to opposite over hypotenuse. And cosine theta is equal to adjacent over hypotenuse. Then if we combine these two together, we get opposite of hypotenuse divided by adjacent of hypotenuse, which is equal to opposite of adjacent. And that is exactly equal to tangent theta. So that's why it's called the ratio identities. Right, and then we've got another ratio identities, which is cotangent theta. And we know cotangent theta is, according to here, cotangent theta is equal to 1 over tangent theta. So therefore, cot theta is equal to cos theta divided by sine theta. All right, so these are the two ratio identities that you guys need to know how to do it. All right, so that's pretty easy, I think. All right, for the first, two sets of formulas, that's pretty easy. All right, so the next one is called the three Pythagorean identities. Alright, so definitely come from the Pythagoras theorem, alright? There are two different ways we can prove the three Pythagorean identities. One of the easy one to prove it is using the equation of circle. Now we know the equation of circle is x squared plus y squared is equal to r squared, which is also Pythagoras. And then we can divide everything by r squared, so we get x squared over r squared plus y squared over r squared is equal to 1. Alright, and then from here, what we can do is, if we just draw a little circle, here's the circle, that's the center, this is the point P, and then we can write point P in terms of the angle theta. Alright, and then this P has coordinate x and y, and then that coordinate x, right, is equal to, and that's radius r. So x is equal to r sine theta, y is equal to r cos theta. Then what I can do is rearrange this one here. Then r squared over sine squared is just going to be, x squared over r squared is going to be sine squared theta. And then y squared over r squared is equal to cos squared theta. And that is equal to 1. All right, so that's the first Pythagorean identities. Now, from these Pythagorean identities, we can deduce another 2 identities. And the last time in the lessons, I remember I showed you guys how to derive this formula here. So let me just remove that part first. All right, so the second one, what I can do is we can say, for example, we have sine squared theta plus cos squared theta equals to 1. We can divide both every single term by cos squared theta. All right, so for example, if we divide every single term by cos squared theta, we're going to get sine squared theta over cos squared theta. Plus 1 is equal to 1 over cos squared theta. All right, now from here, we know from the previous ratio identities, we know sine squared theta divided by cos squared theta is equal to tangent squared theta, and then plus 1 is equal to. Now, using the reciprocal identity, 1 over cosine is equal to sec. So therefore, 1 over cosine squared is equal to sec squared theta. That becomes the second Pythagorean identity. All right, now we can do exactly the same thing, but this time we're going to divide sine squared theta plus cos squared theta equals to 1. We divide everything by sine squared theta. All right, we're going to divide everything by sine squared theta. So if we divide that, okay, so that gives us sine squared theta over sine squared theta plus cos squared theta over sine squared theta is equal to 1 over sine squared theta. Sine over sine is equal to 1. Cos over sine is equal to cotangent or cot. And then 1 over sine is cosec. But remember, there's a square here. So now we've got 3 Pythagorean identities. Now with these 3 Pythagorean identities, that's how I write it, right? Sine squared plus cos squared is equal to 1. 1 plus tangent squared is equal to sec squared. 1 plus cotangent squared is equal to cosec squared. What you need to remember here is when you're using those formulas, you can definitely rearrange those formulas. For example, sine squared theta is equal to, you can move this one over, that becomes 1 minus cosine squared theta. And that is the harder part with trigonometry. Because based on which question you have, all right, you need to be able to rearrange this formula and make one of the terms as a subject depends on the question. All right, depends on the requirement of the question. All right, now we're going to continue. We have I think we'll have one more set of formulas before we can start to try some questions. All right, so the next set of formulas is called the 3 complementary angle formula. All right, the 3 complementary angles. Okay, 3 complementary angles. Complementary angles, which means they add up to 90 degrees. So we do have some information about, some property in trigonometry we can write formulas about. So the first one is sine 90 degrees minus theta. What is sine 90 degrees minus theta? It's actually cosine theta. All right, and vice versa, which means cosine 90 minus theta is equal to sine theta. All right, it's pretty easy to prove it just by using a right angle triangle. It's actually really easy to prove. So that's theta here, that's right angle, so obviously that angle there must be 90 degrees minus theta. So according to this angle here, for example, that's A, here's B, and here's C. So according to this angle here, what we can do is we can say sine theta or sine theta is equal to A over C, opposite over hypotenuse. Then we can write, we can work out what's cosine 90 degrees minus theta. Cosine 90 is adjacent over hypotenuse, which is still A over C. So these two are equal to each other. And that's how you prove it. All right, they are equal to each other. All right, so that's one pair. All right, so sine and cos is one pair. And we do have another, another 2 pairs that you guys need to remember how to do it. All right, so another pair is the tangent one. So tan 90 minus theta is equal to cotangent theta. And then cotangent 90 minus theta is equal to 10 theta. And the last one is sect and cosect. So sect and cosect, their relationship is like a complementary angles. So sect 90 degrees minus theta is equal to cosect theta. And then cosect 90 degrees minus theta is equal to sect theta. All right, you need to be able to use all these, I would say 3 pairs of complementary angles to do some trig identity questions. All right, so that's all the formulas like we need to know at this stage. All right, you are going to learn more trig formulas later on. But now, how do we prove the trig identity questions? So identity means they're equal to each other. So basically, the type of question you're going to get is where the question asks you to prove the left-hand side is equal to the right-hand side. The way you do it is you start from one side, all right? And then you start to prove to the other side. You either can start from the left-hand side or you can start from the right-hand side. All right, so let's start with some simple question to begin with. All right, so let's start with an example 1. It's a proof question, so we're just going to write proof. A. Start with some easy question, all right? So to get an idea, something that's really easy before we move on to the harder questions. All right, so you're going to prove that expression. The left-hand side is equal to the right-hand side. All right, now how do we know which side to start from? Doesn't really matter, all right? It does depend on the question. Sometimes you can start from the left-hand side, all right? Other times you start from the right-hand side, or you can start, you pick, all right? Usually I will start from the side where you have more, terms, you have more expressions. And just because you can do something about it, all right? If you start from a side where on the right-hand side it's only equals to 1, like how do we do the question if it's just one single number? So you start from one side with more stuff in it. So we'll start from the left-hand side. All right, we're going to use the difference of 2 squares, all right? So that becomes 1 minus sine theta. I'm just going to copy the question down first. That becomes 1 minus sine squared theta. Now, I really hope that you remember what's 1 minus sine squared theta. It is actually equal to cos squared theta. Just because I remember I told you guys that sine squared theta, cos squared theta, when they plus together is equal to 1. And I remember I told you guys you need to be able to make one of the term as a subject and rearrange it. All right, like rearrange this one. So 1 minus sine squared theta is equal to cos theta. So that is equal to the right-hand side. So that's a really easy question. All right, a very, very easy question here to prove. All right, okay, so let's do another one. Another easy one here. 1 plus tangent square alpha cos square alpha is equal to 1. All right, so you're going to prove that is equal to 1 on the left-hand side. Everything is equal to the right-hand side, which is equal to 1. All right, now you are not going to start from the right-hand side, okay? It's only equals to 1. No way you can start from the right-hand side and start to prove it. It's just too complicated. So I am going to start from the left-hand side. First step, again, I'm just going to copy everything down. Sorry, that's alpha. All right, so what do we do? That's tangent, that's cosine. How about, let's write 1 plus tangent square. What's 1 plus tangent square, all right? Think about a formula, Pythagorean identities. 1 plus tan square is equal to sec square. Okay. Right, now I hope you realize that sec square is equal to 1 over cos square alpha times by cos square alpha, and then that is equal to 1 when you multiply both. All right, so it looks pretty easy. All right, they're still pretty easy. Not really hard to do. When you spend a few steps, you remember the formula. You should be able to do the question quite easily here. All right, now we're going to do something that's slightly difficult. All right, so I will just do that one here. 1 plus cotangent x over 1 plus tangent x is equal to cotangent x. All right, so this is what the question asks you to do. All right, how do we do it? Well, I am going to start from the left-hand side again. All right, now what do we do? What's the idea behind? You want to prove on the right-hand side is equal to cot x, which is cosine over sine. So how about we change the terms, right? We change the cotangent x and tangent x. So hopefully we can see something. That's the idea. You might have another way to do it. That's great. All right, for trig identity question, you could have more than one way of doing the questions. So at this stage, I think at this stage, the way I'll do it is probably just change cot x and tan x into sine over cos and cos over sine. But as I said, you might have a different way to do the questions here. All right, we can have a look at those methods later on. Let's see if that works. All right, so using the ratio identities, you get this expression. Cot is equal to sine over cos over sine, and tangent is equal to sine over cos. Okay, now what I want to do is times both the numerator and denominator by sine x and cos x. All right, the reason for that is just want to get rid of the denominator. I don't want a sine and cos on a fraction. All right, I just don't want a fraction inside another fraction. All right, so you get sine x cos x plus, well, you cancel this with that one here and cos, and it becomes cos squared x over sine x cos x cosine, and cosine crosses out. All right, you get sine square x. All right, so now what you need to do is you factorize the cosine x out. You get sine x plus cos x. And to do the same thing, you factorize the sine x out. And you get cos x plus sine x. And I really hope you can see, these two terms are exactly the same, which means I can cross them out. So now what you get is you get cos x is equal to sine x. Sorry, cos x over sine x. And that is equal to cotangent x, which is the right-hand side of the question. And that's how you prove it. All right, now sometimes with trig identity questions, in the later stage, you will see a question will probably take an entire board to do, just because there's so many different working out that you need to show, and there's so many steps that follows. All right, okay. I am going to do one more question. Now, it's more important that you do try the questions from the exercise. This is how you can improve, all right? Without doing the question, there's no way you can improve on trig identity questions there. So you do need to know how to improve, all right, based on try different questions. All right. Let's see if there's a question that's good for us to do. All right. How about we do this one? 1 over sec theta minus tan theta minus 1 over sec theta plus tan theta. And the question says, is it equal to 10 to tangent theta? All right, that question. We'll start from the left-hand side. And to save some space, I'm not going to copy the question down. I'm just going to go straight to the answers, all right? How do I do it? We need to prove the right-hand side is equal to 2 tangent theta. Looks like difference of 2 squares. So, this is what I want to do. I want to try to see if that difference of 2 square is going to work or not. All right, making the same denominator. Now, as you can see here, I don't want to do everything in one step. I still want to copy everything down like this, right? Instead of writing sec squared minus tan squared, just to show a few working out. So that's sec squared plus tan squared. Sorry, that's sec theta plus tan theta minus this term here, sec theta. But remember, you've got another minus. These two minus combined, it becomes a plus. All right, looks pretty good now. Now I think you can cross these two out. One is positive, the other one is negative. So you get 2 tangent theta over difference of 2 squares, sec square theta minus tangent square theta. Now, what's this? That's one of the Pythagorean identities, so I hope you remember this. That's 1 plus tangent theta is equal to sec to square theta. So therefore, sec to square theta minus tan square theta is equal to 1. So that denominator is equal to 1. So that becomes 2 tan theta over 1, which is equal to 2 tangent theta, which is right-hand side. All right, so we finished. So as you can see here, definitely you need to try something, right? If you're stuck on something, you don't know what to do, well, you've got fractions here, right? Try to plus the fractions together to see what you get. And the questions are designed that where if you do something towards the end, it can be solved by simply using those formulas around. All right, now this exercise is hard. It's going to take you guys a long time to do it, but definitely to try every single question. Get used to the formula. Try to remember those formats. All right, I know you've got a reference sheet to use, but try to memorize it. It definitely will help you to improve your speed when you do the exercise. Okay, that's it for this lesson. All right, I'll see you guys in the next lesson. All right, thank you.